Let's see if we can get some of these off with a soldering iron then. So let's just heat one side up. Oh yeah, fishy smell. Surprising, these don't look like they've leaked, but obviously have. Yeah, struggling to get that tinned, so I'm going to need to pop a little bit of flux on that. Tin the end of the iron. So all I'm doing is just levering these from side to side. It's not the best. You do risk a bit of pad damage, but there we go. Is that one off? Other ones, this one's pretty close to everything here, so see if we can get that off. Yeah, they are corroded. What we'll also do is check this T11 a minute, just to make sure that that it's not open circuit, because that's going to cause a whole lot of headache for me. So let's just put that out the way. Let's tin the iron, stick it around this way, so if we can get the positive side lifted. There we are. Let's say the old twisting it off method works very well, but the problem is if you've got any corrosion on the board, it can rip the pads. So that's that one off. This one, can I get this one? Can't really get the soldering iron in on this one, I don't think. I might be able to get the other soldering iron in there. The other tip, I mean. Might be able to lever it up enough, but come. Are you going to be nice? Yeah, okay, maybe I can slide underneath and take the other one off. There we go. Those three I can get off of hot air. This one I can't, because it's right by these plastic connectors. I've done it before, but you've got to basically really mess about and what am I trying to say? You've got to basically put a load of tin tape. I mean, I use this aluminium tape stuff here to blank stuff off, ready for desoldering. But some you can get away with, some you can't. So I've not got the soldering iron too hot. There we go. There's another one. Right, so I need to set up just to do those with the hot air a minute. They should come off a bit easier, so I'll just get that set up and join me again. Okay, right, I'm all ready to take them off with the hot air. Now, hot air station, I've never really known what the best settings are for it. So I'll tell you what I'm using if I can unravel it from the microphone, so apologies if there's loads of noise. So I tend to use a temperature of around about 380. Airflow, about a third on the airflow. So you want some decent tweezers to get these off. So I'm putting the airflow across this way. I've got an angled, fairly thin nozzle on. Just going to preheat the area. You don't want to keep the heat on these for too long because they'll just explode off the board. So you can see I put tape on. Let's pull that one first then. So that one. This one. Oh, we've got the transistors come off as well. Nice. And that one. So we've got a little transistor come off there. Yeah. Okay, I'll have to put that one back on with a soldering iron, I think. So let's get that little transistor back on. I'm sure you can see which one it is. Let's just go in a bit closer. It gets a little bit grainy in close, unfortunately, but it's that little transistor there, if you can see it. Okay, there's our little transistor that's come off. Let's just get him out of the way with the tweezers. You can see all that brown muck. That's that is electrolyte from the capacitors. So I'm just going to put a little bit of flux on there. Soldering iron set to 350. I'm just going to go and refresh those pads. Also do these while I'm at it as well. While I'm in here with a soldering iron, might as well go crazy. So I'm just putting a little bit of fresh solder on these pads to get rid of the corrosion with some flux on it as well. You do need flux to get rid of all the corrosion, so I'm just sort of scraping over. Bit of corrosion there, not too bad there. Yeah, a little bit of corrosion on that one. Let's get a cotton bud, give that a bit of a clean off. Yeah, so there is a bit of corrosion on this pad back here, definitely. So there we've got our pads all ready to take that transistor back. So have a look at him, make sure he's not damaged. No, he's not. So what I want to do is just wick away. Just going to wick away solder on 2 of these pads. In fact, we've actually lost a pad there, I think. What is that connected to, I wonder? Oh, that's a diode. That's lucky, so that pad's actually not connected to anything. Right. So put that on there. So I've left a bit of solder on this end. So say there was a bit of corrosion there, whether that was down to me or the corrosion, I don't know. So what I'm going to try and do is just get it tacked. There we are, it's back on. So we'll just check that diode does run that way. Let's get the diode tester. So let's just go, make sure that is the diode there. The other way. Yeah, there he is. And there's nothing on that other pin at all, so that's a bit of luck. So I will put some solder mask on that just to secure it better, but luckily that hasn't caused an issue. I thought it was a transistor, but it's one of those three-legged diode packages. So there he is. Let's give it a bit of a clean up. Make sure it's all okay. Use the old brush on that. There we are. Back in business. So I can take that off now. So T11 is the one that gets the hammer, because that's, I mean, you can see there is quite a lot of brown around T11, look. So you can see the electrolyte that has come out of those, especially there, look. So let's see if we can get that off a minute. So that's already gone in underneath there. So it's going to be interesting to see whether that's actually taken it out or not. So being careful not to get any heat around there. So to get at that, we've got to flip the board, and we've got to take this board off. But a bit of a pain, but it is worth doing. So that does need to be checked, because I did say to the customer I would give him an idea of the costings on it. So that's the pad there's not particularly great, so let's give that a little bit more flux. The flux isn't going to hurt that transformer. It's a no clean flux. Yeah, you can see, because the that pad's right. This one here is the one. You can see the solder mask's flaking a little bit. Yeah, okay, that'll be fine. So I've got to clean these off with the wick in a minute. Okay, so let me get this board off, and join me again, and we'll just check that transformer. Right, well, I thought I'd bring you in just to show you what's involved getting this board off. You've got to take the aerial connector off. It does make it easier if you get this aerial connector completely off the board. So I've done this a few times. Unfortunately, it's a bit of a pain, but it's going to be worth it in the long term. So let's just take this connector off. out the way. Some more screws. Three in total. You've got to take the ferrite rod connections off. The board should come up now. There we are. Okay. Right. I'll get set up and show you what's going on. Right, we're set up. Middle of the screen you can see T11. Now to me, that looks like that has been changed before. That certainly doesn't look like factory solder. It's really blobby. So we've got this side where this capacitor is. This is the primary across these two pins. There is a center tap, but that's not actually connected in the circuit. But you know, we should have continuity between these two outer ones, and both the outer ones and the inner. Secondaries over this side, just a 2-pin secondary. Obviously these pins are just a ground. So let's just start on the primary first then. So we should be seeing somewhere around about 20 ohms on this, hopefully. If I can get the probes to stay still for a minute. That's good. So the primary is fine. Let's just check to the center tap. Obviously it's got a connection there. So we've got 13 ohms that side. Across this side. Should have slightly different because there's different windings. Yeah, 5.5 ohms. Right, here's the moment of truth, secondary. Yes, 7 ohms. So that transformer is good, but it has been changed. That don't look like factory to me. I mean, if you look, that's T11. If you see the blobby soldering around that. Now if you look at T10, which is exactly the same transformer, look at the difference. So, you know, that has been changed. So this radio's been back in for a service at some time in its life, and that's probably got eaten away. You know, it beats me why they wouldn't do the capacitors while they were in there. There you go. Okay, so what I've just been and done is just tinned the all the pads with some flux just to clean off any of the muck. So I'm going to wick that off now because we need to prepare for the new capacitors. I need to just check with the customer which way he wants me to go, because I can do it in either SMD electrolytics again or tantalum SMDs. So I think I'm going to need to put a bit more solder mask on that particular pad there, because it's got quite a lot of corrosion around it. So I'm just going in, taking off the solder that I just put on basically. Try not to hit any more components off the board. Just using some solder wick here. Right. Let's give that a clean up with a cotton bud. You get through a lot of cotton buds doing this job, I tell you. Oh, I missed one there. So I'm just using isopropyl on the cotton bud to just get Get rid of the excess. So I've got plenty of pictures of these as well. I wasn't really too fussed about making notes of what went where. So just cleaning this back up again. I've already been over this and cleaned it once with isopropyl, but I've just used fresh solder, which has got flux in it, so I'm just getting rid of that again. Right, just switch camera. Okay, so you can see this pad by T11. You can see that the solder mask has come away either side of it. That's basically because the corrosion's got in underneath it. So what I want to do is just scrape away any loose stuff around that. I'm just using the tip of tweezers just to get in around it. Let's get rid of the corrosion. You can see the board's slightly bubbled up in place. It's not too bad actually. I've had a damn sight worse than this. This is one of the better ones. Right, so just sort of scraping it back to where it's solid. Just using the tip of the tweezers, soldering iron. What are you going on about now, Graham? So there's various other places you can see here as well. You can see this one here. We've got a bit of solder mask disappeared, so I need to do that because it might bridge just between those two pads. A little bit there. I don't think that's going to. Yeah, that might bridge as well. So there's 3 areas there that I'm going to have to add some fresh solder mask. Also, going down. Where are we now? We need to go that way. Got a bit of corrosion in there, but I don't think that's going to give us too much trouble. But yeah. We have got a potential of bridge in there, so we need to put a bit of solder mask on there. Again, it's worth scraping it off anyway because you have got corrosion there and it gets trapped by the solder mask. So yeah, I need to do those a minute. Okay, well, to do the solder mask, I'm going to be using this stuff. It's a UV cure solder mask, and the beauty of UV cure is once it's cured you can carry on working straight away. I mean, normal solder mask you've really got to let it go off for a little while, and I've got this UV light which I picked up off Amazon, and that with the combination of a bit of hot air, it does go off quite quick. But the key to this is not to put it on too thick. So I'm going to switch over to the other camera, and we're going to put some on. So all I'm going to do with this is I'm just going to squeeze out a little tiny bit. I'm going to get these really pointy tweezers. I'm going to just put a little bit on the top of the tweezers, and I'm going to use the tweezers as sort of a paintbrush. So let's crack on. Ooh, as always, too much comes out. That's that one. So you can see that the copper has gone. I'm going to need to turn this one around this way so I can get to these. So if I can find where I am with the camera, where are you? Over here. Right. Whee. There we are. We've got a bit of glare on it now. So same again here. Cool. If you didn't do this, it wouldn't hurt really on this particular pad, because it would just make a horrible blobby lump of solder. But certainly on this one here, if you didn't put it on, you could potentially bridge across. Okay, that's that one. And just on this one here, and I'm also just going to put a little tiny bit on that leg, because this does dry like a glue. I think that's all the repair work there. So the next job is to hit it with the UV. And a bit of hot air. So I'm going to turn the temperature of the hot air right down as low as it goes. Turn the airflow down a bit. Get that ready. I don't need it on yet actually. So let's give it a bit of a cure first. So I'm just popping the UV light on it as close as I can to it. Just let that rest for a minute. It doesn't take long to UV cure this with a bit of hot air. And luckily, some of the guys on the console repairing Discord, Mr. Coder's Discord channel, suggested I try this, and it does work. So I'm going to pop the hot air on. So I've got it on 100 degrees, so I can sort of keep my hand fairly close to it. I'm just going to fire that in underneath. It's not going to melt anything. Just lets it go off a lot quicker. It's gone off already. So same over on here, exactly the same. Just let that cure for a minute on its own. Just fire the hot air in underneath. So I'm just going to leave that propped up there for a few minutes and let that go off. So join me again in a minute. Okay, here we are, all set. There's our solder mask, all gone nice and hard. And you can see the little diode leg there, look. That's gone nice and hard as well. So that's glued back onto the board nicely. So now really the next step is to get this board recapped. So I've got to contact the owner really now, just find out which way he wants to go. Does he want to go down the tantalum route and have it done with SMD tantalums, or does he want to just go back to the slightly cheaper option of SMD electrolytics? So I need to get that sorted, and then I can crack on and get them done. I probably will, in the meantime, get the caps off the other board in here. There's going to be little quirky bits on this, so I will bring you in from time to time just to show you what I'm up to. You know, we might be able to get most of them off with air. But we're probably going to need to take these connectors and take this board out to get to them. So, you know, a little bit involved. It is a pain in the neck to work on these. They are really a pain to work on. As you can see, I've got loads of bits so far. But luckily, I've done quite a few of them recently, and I'm fairly au fait with how they all go together. If you haven't done one of these before, be very careful and probably follow this video along, and it'll help you get it apart. If you don't want to do these capacitors, obviously you can get someone else to do it that's got experience of doing them. Of course, you're welcome to send it on to me to repair for you. So let me have a word with the owner then, and find out which way he wants to go, and then I can start doing some more caps. So catch you in a bit. Okay, well, I've had a word with the customer now, and he's opted for tantalums for this job. So a bit more expensive, probably about 10 or more. There's a lot of caps in this, and tantalums are expensive compared to the normal electrolytics. So I'm going to start populating this. So I think we'll start here and work our way down, and then finish off with that one. So I've got you underneath the overhead camera. I'm probably going to need to just turn it around a little bit to gain access, but hopefully that'll be fine. So you don't need to see any more of me. I'll get myself out of the frame, and we'll crack on and get this baby done. So first one going in is going to be a 22 at 6 volts. I've had to order some of these in because they're getting a short supply. But no, I haven't ordered any of those in. I tell a lie. Right, let's find my favourite tweezers. If I can find my favourite tweezers, I think that's them there. No, that's the bendy ones. I want the straight ones there. So that's the first one that's going to go on. And you'll notice with tantalums you've got a stripe across them. Let me just get you in a bit closer. So you can see we've got a stripe across there. If we can get a better picture. Not really. So yeah, you've got a stripe. That stripe actually marks the positive, not the negative. So on the electrolytics, it's the other way around. The stripe marks the negative. So it actually is that way orientated. First thing to do then is to just add some flux to the board. Don't need a lot, just a little tiny bit. What I'm going to do is going to tin the positive. I'm using my bent soldering iron tip for this. I find it easy to get in over the top of stuff. So I've just tinned it. I'm going to grab the tantalum with the tweezers. I'm going to sort of aim it up. I'm going to heat that pad and drop the tantalum on there. Just going to give it another heat with a bit of pressure on top just to make sure it's sitting flat. It needs to come across a little bit, so let me just move it a fraction. That's fine. So then other side, just going to add a little tiny bit of solder. There we are. One done. God knows how many to go. So what I think I'll do is I'll populate a few more of these, and then you can join me for the final ones. Okay, well I was going to bring you in there, but I totally forgot, to be honest. Never mind. Anyway, they're all done. Look, this is this board. So we've got some 22 there and there, 47 at 6, two 2.2s. Say some of them are different colours because they're different manufacturers, that's all. I think these are Vichy. I can't remember what these are now. Chemet, I think. Another one down here, 47, and the one nestling in between this can and the filter, another 47. So that's that board done. Next board is in underneath all this jumble. So what I want to do, I'm just going to make sure that all the transformers are okay on this one, and then it's a case of popping it over, and we've got to sort out all the SMD caps in this board here. So that's going to be the next step.